questions from lesson 5. So I'm going to be doing question 6 and question 7. Question 6 says the value of n to the nearest 10th for which the statement below is an identity. So we've got a left-hand side and we have a right-hand side. We're going to be solving for n. So what I'm going to do is I'm going to take the left-hand side of this identity and using common denominators, I'm going to add these two fractions. So I have the two fractions written over here. This is the left-hand side. Before we start figuring out what our common denominator is, remember that every time you have a binomial, binomials always deserve brackets. So put your binomials in brackets. Okay, I've got a cos of x in the left-hand fraction. So I'm going to put in my right-hand fraction a cos of x in the denominator. Then in this fraction, I have 1 plus sine of x. So let's put the 1 plus sine of x over here. Okay, what I now have is I now have common denominators. Cos of x and cos of x, 1 plus sine of x, 1 plus sine of x. So when you're adding fractions, you just write your denominator. So cos of x, 1 plus sine of x. And then with the numerators, we're going to add these numerators together. Now I've got two binomials here, so what I'm going to do is I'm going to get rid of the brackets by expanding these two or foiling, distributive property, whatever term you are comfortable with. So 1 times 1 is 1. 1 times sine of x is the sine of x. Sine of x times 1 is sine of x. And sine of x times sine of x is sine squared of x. And then we've got a plus, and over here we've got cos squared of x. Hopefully, many of you could see the identity, but there is an identity in here. So sine squared of x plus cos squared of x, that is going to be 1. So I'm going to take this out and I'm going to put a 1 in its place. And then the other thing I'm going to simplify is sine of x and sine of x would be 2 sine of x. So what my numerator would simplify to be is 1 plus 2 sine of x plus that 1 all over the common denominator of cos of x, 1 plus sine of x. Okay, from here, let's simplify the numerator. 1 and 1 is 2. So 2 plus 2 sine of x all over cos of x, 1 plus sine of x. So many of you will get to this step and not really see anything else you could do, but there is actually one other thing you could do. And what I hope everybody sees is you could factor out a 2 here. So if I factor out the 2, what I would have is 1 plus sine of x as the second factor. In my denominator, I have cos of x and 1 plus sine of x. And then now, 1 plus sine of x and 1 plus sine of x cancel. And what we are left with on the left-hand side, so the left-hand side of my equation is 2 over the cos of x. The right-hand side, if I go back up, so what was on the right-hand side, n over cos of x. So I cleaned this up, right? And I've gotten that to be 2 over the cos of x. And the right-hand side is going to be n over the cos of x. Okay, so from here, we need to solve for n. So let's just cross multiply and then isolate n. Or you could say, sorry, another thing you could do is you could cross multiply, right? 2 times the cos of x would be 2 cos of x is equal to n cos of x. Or you could just say, okay, n is being divided by cos of x. What's the opposite of dividing by cos of x? Multiplying this side by cos of x, multiplying this side by cos of x. And then what we are going to be left with is n is equal to, and cos of x and cos of x will cancel, so it's going to be equal to 2. If I go back up though, what it actually says is it says what's the value of n to the nearest 10? So if we're writing this to the nearest 10, n is equal to 2.0. Just to quickly show those of you that didn't see that, you could have cross multiplied, and I'll just quickly do that. So 2 over the cos of x is equal to n over the cos of x. Cross multiplying, we would have 2 times the cos of x is equal to cos of x times n, or n times cos of x. We need to isolate n, divide this side by cos of x, divide this side by cos of x. And now you've isolated n, and n is equal to 2. So we get the exact same answer, cross multiplying. Okay, homework question number 7. It says if p over 2, and then it gives you, it sort of looks like a mess on the left-hand side, and it says that's equal to 4. What's the value of p? So what I want you to see is, because I have a p over 2 and a p over 2, we could factor out that p over 2. Okay, so let's factor out p over 2. And what we would get if we factor out the p over 2 is we would get cos squared of pi over 5 plus sine squared of pi over 5 is equal to 4. It might be hard to see this, but this is one of your Pythagorean identities. This identity here is sine squared of x plus cos squared of x is equal to 1. So remember that for this identity, when we prove this in class, x could be any number, and if you have sine squared of x and cos squared of x, that is going to equal 1. What they've done is they've just said, well, let x equal to pi over 5. So it doesn't matter what x is, but this is what they chose x to be. X is equal to pi over 5. So just imagine that this is our x. So it's cos squared of x and sine squared of x. Even though x is pi over 5, this identity is 1. So p over 2 times 1 is just p over 2, and that's equal to 4. We got to isolate p. P is being divided by 2, so multiply both sides by 2, and we're going to get p is equal to 8. And then it says again, the value of p to the nearest tenth is going to be 8.0.